All right, so this is part 2 of 1.6. In part 2, we're going to talk about if a function even has an inverse, because not all functions have inverses. And the way you can tell if a function has an inverse is to see if a function is one-to-one. Okay, so a function f has an inverse if and only if. So in the future, when you see this term, if and only if, I'm going to abbreviate IFF. If and only if it is 1-to-1. Okay, so that's how you can tell if a function has an inverse. So the next question you would probably ask is, well, how do you know if a function is 1-to-1? Glad you asked. 1-to-1, a function is 1-to-1 if every output, every output has exactly one input. In other words, every y value has exactly one x value, right? And so previously, right, the definition of a function was every input has exactly one output, but the definition of 1-to-1 is every output or every y value has exactly one x value, right? And this implied definition, right, that it's already a function means two things, right? A function, every x, right, every x has one y. And this definition, right, a function's 1-to-1, every y, actually, let me re-erase here. So every x has one y, right? This is the definition of a function. And every y has one x, right? This means 1-to-1. So if a function's 1-to-1, every y value has exactly one x value. But because it has the word function in it already, it's already implied that every x has exactly one y. Okay, so every x has exactly one y, every y has exactly one x. You know that your function is 1-to-1. If it's 1-to-1, what's so special about it? The inverse exists. All right, so there's 3 ways you can determine if a function is 1-to-1. Hence, it has an inverse, right? Numerically, look at the table. Okay, so if your table, let's say you have 1, 3, and then you have 2, 3, right? This is clearly not 1-to-1, right? The y value 3 has more than one x. Graphically, how would you determine graphically if a function is 1-to-1? Use HLT. Okay, HLT stands for horizontal line test, right? So over here, if I have an absolute value function, right, this clearly is not 1-to-1, right? It fails the horizontal line test. The horizontal line test basically states that if you draw a horizontal line anywhere on a graph, it can only touch once. If it touches more than once, it fails the HLT, hence the function does not have an inverse. Okay, and algebraically, this part might be new here. If f of a is somehow equal to f of b, right? 2 y values equal each other. This implies that the x value has to be the same. Okay, if f of a is equal to f of b, then a has to equal b, because remember, each x can only have one y, right? Each y value can only have one x value, right? Okay, so let's show that in this quick example over here. Is f of x is equal to x squared? Is it 1-to-1? I'm going to justify going algebraically first. Okay, so algebraically, how would you do that? Since this part is new. So we are going to assume that f of a is equal to f of b, right? So if I say, what is f of a? You would say a squared. If I say, what's f of b? You would say, that's b squared, right? Now, if you take the square root of both sides, right? If you take the square root of both sides, The square root of a squared could be plus or minus a. The square root of b squared could be plus or minus b, right? You could have a equals negative b, or you could have a negative a equals b, right? These guys don't equal. The a doesn't necessarily equal b, hence not 1 to 1. Hence, there is no inverse. Or sorry, there is no inverse. So algebraically, I verified that, right? And then, of course, graphically, you already know what this graph looks like. F of x is equal to x squared. Clearly, it's going to fail the HLT, right? Fails HLT, right? If I used, 2 comma 4 over here, this is negative 2 comma 4. Notice the y value of 4 has more than one input, right? And so numerically, right, you can do the same thing over here. Numerically, here's x, here's f, negative 2, you get 4, positive 2, you get 4, right? You could say output y, output 4 has more than one input. It's not 1 to 1, and inverse does not exist. DNE. Okay, so for a simple example like this, I showed you algebraically, which is kind of new to you, right? The a and the b have to equal, and I just showed you in this example, a does not equal b necessarily because of the plus or minus. Graphically, it fails the HLT, and then numerically, right, you can see in the table, this fails the definition of 1 to 1. Remember, each output can only have one input, right? The output 4 has negative 2 and positive 2 paired to it. So therefore, it's